Welcome to module 17. In this module, we will learn about hybrid LCA, tiered hybrid LCA and see an example on hybrid LCA. So, hybrid life cycle analysis. What is the motivation behind hybrid life cycle analysis and what it exactly is? So far in the course, we have learnt about process LCA and economic input output LCA, and we have seen the computational structure for both. We have seen that both have advantages and disadvantages. So, when you talk about process LCA, we see that we have to look at the most important processes. It is slow and tedious to get LCI, and since we are focusing on most important processes, we have truncation errors. But of course, it is more accurate because you are looking at the more specific processes that are important for your LCA and your system boundary. When we go to the economic input output model, we know that it is fast because we have the input output model already available. All we need to do is set the final demand for our system and then calculate the total impact using the Leontief model and the emissions and resource coefficient. Of course, there is no truncation error except for regional or national boundary if you are looking at one region, but we do not miss any of the important processes or any of the indirect impact. The challenge of input output model is, of course, building this input output model is a very data intensive process and it is slow to get that model. But once it is already available, we can do fast calculations without making much of the changes to the model itself. The another important challenge in the input output is that it is more aggregate. So, if you have a specific product that can be in the same sector, because we are aggregating lot of the similar processes in a sector, that specificity is lost. So, economic and sometimes EIO is not mostly available for current period because you have to collect a lot of data to build that model. And then there is also economic price fluctuations that can change the economic structure that we are already looking at. So, of course, both input output and the process LCA have some advantages and disadvantages, and many a times there is debate between the analysts whether you go to a process LCA or an input output LCA. To solve that debate, what scientists in the literature of LCA have done is created what we call as hybrid LCA. So, what does hybrid LCA does? It combines the strength of both process LCA and EIO. So, what we do is we utilize the EIO data for system comprehensiveness and process data to improve accuracy or capture the specificity of your process. As we go further in the module, we will see how that is done. But the whole idea is that if you have some specific process, then you want to include the accurate data for it. For many of the upstream inputs, you might not have the specific process information, and to model that, you generally just use the input output model. So, nowadays what is happening is to really overcome from this truncation error that we see, because we know that there can be very high indirect impact. Lot of analysts are preferring to move towards the hybrid LCA. The only challenge is that we have to be cautious of double counting, and we acknowledge that there can be double counting when we are doing hybrid LCA. Okay, so the types of hybrid LCA, there are first type is the tiered hybrid LCA that was proposed by Bullard in 1978. So, it has been a long time since this kind of hybrid LCA theory has been aligned and has been available, and it is a combination of process LCA and IO LCA. The way tiered hybrid LCA works is that some inputs such as actual process and downstream requirements such as construction are modeled as process LCA, because lot of these which have direct access to data have more availability of information to be able to directly model it as process. So, we use the process LCA for much more of the immediate life cycle stage that is part of our LCA study. Some of the upstream requirements such as materials extraction or manufacturing etc. are modeled as EIO LCA, because we might be buying a piece of equipment and we do not know the exact process by which that piece of equipment has been manufactured. So, in that case what we will do is we will go to the economic model and just look for the final demand from the equipment manufacturing sector and use the input output LCA model to get the impact. And then we combine the information from the process LCA and input output LCA to get the total impact. This process is the tiered hybrid LCA. Then we have what we call as IO based hybrid LCA. In this case, we use the input output model, but we further disaggregate the sectors of interest in different much further fine detail by using the process information. So, let us say you are looking at an energy sector and you want to distinguish between wind energy and solar energy. For that, you can use the input output model and further disaggregate input output wind energy and the solar energy sector to create a new input output model, and this will be also hybrid, because what you have done is you have used the process information about the energy requirement or the flow requirement for solar versus wind to disaggregate the model. Of course, in this approach you need to have lot more information about how the sectoral interactions can change when you disaggregate, and this becomes a little cumbersome or challenging. So, input output based hybrid LCA is good, but it is a little challenging to perform because you are going to deal with a large sectoral economy and update the model itself. Then we have what we call as integrated hybrid LCA. In this, process scale matrix is integrated with the input output matrix itself, and here we are updating the whole model by looking at the process and the IO interaction and the IO and the process interaction. So, this is again creating a new kind of matrix algebra where we actually integrate the input output model with the process process model. So, here in this module I will only go through the tiered hybrid LCA and look at that example, because tiered hybrid LCA is much simpler. However, there is double counting issue. So, people do want to improve by going towards the integrated hybrid LCA or IO based hybrid LCA. So, let us look at the tiered hybrid LCA in little bit more detail. So, in tiered hybrid LCA, let us consider this LCA, and we have two processes in our system boundary. So, one is the process for manufacturing the product. It can be any product that we are looking at and we are using the product. So, these two processes we have full information of input and output. So, we have the process scale emissions for both of these life cycle stages, and we know that for the process of manufacturing we have electricity, natural gas and steel input. So, we have that upstream information, but we do not have information about the process of steel manufacturing or process of natural gas and process of electricity generation. So, what we will do is that we will use the input output model to look at the how much emissions is required for generation of that much electricity, steel and natural gas, which is the input to our process, and then we calculate the total EIO scale emission. We have the process scale emissions from our process LCA, and then we basically calculate the total emissions or total impact as EIO scale emissions for or plus process scale emissions. So, the tiered hybrid LCA is actually very simple, because what it is doing is that instead of us missing the impact of electricity, natural gas, of steel, because we do not have the process information, we are going to input output model and get that information. So, of course, doing the input output LCA is very fast. All you need to do is calculate the total amount of final demand for electricity, natural gas and steel sector and input that into our Leontief model like we did in our last module and get the total impact. So, that is how the tiered hybrid LCA is done. So, the LCI components for tiered hybrid LCA, you have a process scale part, you can calculate all the energy, emissions, etc. associated with the processes being considered. So, for this, remember we have learnt about the process LCA network algebra as well. So, you can go back to that and calculate your total impact using the equation of BA inverse F, where your A was the technology matrix. For the EIO scale part, you can list all the inputs to each of the process stage for which you do not have the process information and you want to use the model of the economy to calculate impact. So, what you need to do is you need to calculate the final demand for each of these inputs from that particular sector. So, what you would do is we have the inputs, we map it to the sectors. So, let us say we use the next classification or the North American industrial classification system or the Indian classification system. We map the inputs to the sector, and then for each of that sector we can get the final demand in terms of dollar by using the price. Once you have that final demand in terms of dollar, you can use the Leontief model to get the impact. So let's look at an example of tiered hybrid LCA so that it becomes more clear of how we actually perform a tiered hybrid LCA. So this example I have taken from literature that is already published. So we'll just go through the components of the LCI and how that emissions impact was done. So this example is a case of a vehicle fuel tank, and the idea was that the General Motors, which is a automotive manufacturing company, has been remodeling its vehicle fuel tank for lighter weight vehicles so as to improve fuel efficiency. And what GM scientists were interested in understanding, if they are converting from a steel fuel tank versus a plastic fuel tank, of course the plastic had to be something that can go through high temperature and all of that properties that is required was matched, but then they wanted to really look at that how this impacts the total emissions or total life cycle emissions for the vehicle tank manufacturing by GM. And of course, since the materials are completely different, there is a significant difference in design of both fuel tanks, mainly in terms of what materials are input, how much energy would be required in molding, how the process will be dealing with the scrap and all of that. So of course, there is a design change that happens. So you can do a LCA for vehicle fuel tank, but the challenge is that if you do an LCA for vehicle fuel tank, what will happen is that both types of fuel tank will come under the same sector. So of course, we cannot do an economic input output LCA because that does not show the difference between a steel fuel tank and plastic fuel tank, because it comes from the same sector, because input output aggregates the type of processes, and both will be the same type of processes. And if you do the process LCA, of course, it will become tedious and you may miss several upstream impacts. And therefore, the authors of this paper from which this study has been taken went and did a hybrid LCA. So let's see how they did that LCA. So for the EIO LCA, if you have to use the input output LCA, the sector that goes is the motor vehicles part manufacturing, is which makes the vehicle fuel tank. There is no granularity to differentiate, and the process LCA for that, we getting all the data for upstream raw material manufacturing will be tedious due to large number of inputs in manufacturing. Hence, the authors decided to do a hybrid LCA. So before we go to the hybrid LCA, what we will do is we will look at the whole manufacturing of the vehicle fuel tank. So the life cycle stages that we can look at is the raw material manufacturing and acquisition, then actual fuel tank manufacturing, use on automobile, so how much soever time it's going to be used, then end of life, which is the shredding, and the shredding of the steel fuel tank and the plastic fuel tank will be different, and then recovery for recycle. Of course, steel may be fully recovered and plastic may not be recovered. When we look at the plastic fuel tank, the inputs that are needed are plastics, of course, energy, then you have some dies and tools, you have electricity, and then in the use phase, because it is a lighter material, it might have a different gasoline use due to weight of plastic fuel tank. Similarly, for steel fuel tank, we will list all the inputs. So we have steel input, energy, dies and tools. Of course, your dies and tools here, you might be using lathe machine, and in the case of plastic, you might be using forming machines or the extruders and things like that. So of course, the kind of dies and tools that are used for the manufacturing of these two vehicle fuel tank using different materials will also be different. Of course, the electricity, which is the energy input, that might also be different based on the material type. And then during the use phase of the vehicle fuel tank, you have different gasoline use due to weight of steel tank. So when they did the tiered hybrid LCA, this was a 1999 study by Joshi. What they did, that this whole part of fuel tank manufacturing, use phase, and then shredding, and then the recycling, this was all done using the process LCA. and then you have the inputs from the economy. So, the steel sheet, dies and tools, electricity, etc. was the input from the economy, and for the environmental impact they had welding emissions and shredder residue. So, you can see that they also model the recycle, that some of the steel mill products are going back to the economy. So, what they did was that this was the process part where you have each of these processes for which the GM actually could collect data on site and look at the recycling and everything and the shredding of the fuel tank. But anything that was coming from the economy where GM as a company did not have a direct interaction to collect data, that was seen as an input from the economy and as a total impact coming from the input output LCA. So, the LCI for tiered hybrid LCA or the EIO part was basically your impact of material inputs was modeled with EIO LCA. So, for example, for manufacturing stage we have steel and electricity, that was modeled as input output. Material input for use fees, differential amount of gasoline. So, how much that differential amount of gasoline is also coming from economy. So, that was also modeled as an input output LCA. Then we have materials input for shredding stage. While they knew what is happening in the shredding stage, the requirement of electricity and equipment is coming from the economy. So, that was also modeled as EIO LCA, and also the materials input for electric arc furnace remanufacturing. So, all of these inputs for different processes was estimated from the process, but then the total input was converted into final demand into dollars and fed into the input output model for the US economy. So, here is how the data looks. So, you can see the inputs to the tank manufacturing, you have all the, and then they mapped that input to the US IO commodity sector and then looked at the IO sector, and each of the input amount was calculated into dollar value of input per tank. So, if you are manufacturing per unit tank, how much is the dollar input? So, you can see that for steel one we have carbon steel sheet of about $23 per unit, and then also they have inputs to the use phase, the gasoline that is being modeled as petroleum refining in the economy, and you have the total amount of input that you need. So, auto shredding. So, that's how what they did is for each of the life cycle stage, both for the plastic vehicle fuel tank and for the steel vehicle fuel tank, they connected it with the economy to do the tiered hybrid LCA. And also you see that for the recycling they gave a credit of -$4 because that is the amount of steel that they are giving back to the economy, and therefore, there is a reduction in the demand of steel in the economy. So, to model the recycling aspect of the steel from the input output, they could give back as delta F equal to minus dollars. So, the process component, fuel tank manufacture, energy use, emissions, all of that was estimated from the experimentals or from the measurement. Use phase emission, combustion of gasoline, they could estimate based on the vehicle fuel tank efficiency over the lifetime. Shredding phase also they could get the direct energy consumption, and then the recycling phase also they could calculate the direct energy use and emissions during that particular recycling phase. Once they had all the information, they calculated total impact using the process LCA, they calculated total impact using the Leontief model. The whole work was in the setting of the Leontief model, which was not very difficult when they had all the input and they mapped to the sector in the economy, and then they aggregated with impacts from process scale. So, that is how a tiered hybrid LCA is done, and hopefully this example of the vehicle fuel tank based on plastics and steel and how they mapped each of the processes upstream to the economy inputs from the economy would clarify how you can set up a hybrid LCA. Going forward in the course, we will see some examples of hybrid LCA setup so that you get a practice of how to do a tiered hybrid LCA. Now, we will move forward and look into the theory of some other types of hybrid LCA. Let us look at the IO based hybrid LCA, which is going to where we disaggregate sectors. So, in this method what we do is that the sector which is related to the commodity of interest is disaggregated to represent the commodity as independent sector. So, what do we mean by that? So, sometimes in the economy one sector can make multiple products. So, for example, the energy sector may combine coal energy, fossil fuel energy, renewable energy such as wind and solar. But let us say we only want to study the impact of solar energy generation. In that case, we really need to update the model so that we segregate the impact of solar energy from the wind and the coal energy. So here what we will do is we will create a new sector in the economy, and that sector will represent wind energy generation in the economy, and then we can use our usual IO model of I minus A inverse F by setting the final demand for the wind energy sector. So let's say if you want to, another example is, let's say we want to study IO impact for paper cups, then to do an hybrid LCA we will disaggregate the paper board container and boxes. So that's the sector in the economy that, this is for the US economy. So that's the sector in the economy that represents all the paperboard container boxes manufacturing. So what we will do is we will segregate it into one sector that is only making paper cup, and then all other products in paperboard containers manufacturing. So that way when we have a new sector where we have paper cup sector, so to study the impact we will only set the final demand equal to some amount of X dollar for paper cup, and for rest of the economy we can set it at 0, so that we can only study the impact of paper cup manufacturing from that particular economy. So this is what we call as the IO based hybrid LCA, because we are still doing the input output, but we are disaggregating the sector by using more detailed information about the paper cup manufacturing to disaggregate that sector. So here the first n minus 1 sector will be same, we do not touch anything about that, but let's say we are splitting the nth sector into 2. So then in the new model of the economy, if the original economy model was n by n matrix, our new model will be n plus 1 times n plus 1, where the new sector is what is the sector for which we had more process information available, and now we are interested in studying that. So that is the IO based hybrid LCA. The next one is the integrated hybrid LCA. Here the process LCA matrix, so remember our A or technology matrix that we made in the process LCA part, that we mesh with the IO matrix to create an integrated matrix. So now instead of just looking at one sector and the process information and disaggregating it, we are bringing in the full process LCA model as a matrix. We have the input output model as the direct requirements matrix, and we create an integrated matrix of flows to have a comprehensive economy that has the details of the processes, but also the aggregation of the input output. So most of the time these kind of models will be mixed unit, because you have the process model mostly in the physical unit, economic model in terms of economy, and you will have two integrated model. So because this course is at a undergrad level, this integrated hybrid I am keeping it out of the scope, but we will definitely look at just the theoretical examples of doing this. So let's look at some of the advantages and disadvantages of hybrid LCA. So tiered hybrid LCA, we saw an example, and we'll do a quantitative example for it. It is really easy to use because all you need to do is do your process LCA, do your input output LCA, and then combine. But here the weakness is the problem of double counting. Sometimes whatever processes you are modeling are also embedded in the input output model, they are already existing. So what you are doing is, when you are doing your input output LCA, you are not eliminating that process that you had already included in your process, so in that process LCA, and that is why there is a double counting. So there are a lot of case studies that are available, but and this table is taken from Sangwon Soo's paper in Environmental Science and Technology, and you can definitely read it if you have access to it, and you can go through more case studies. Then we have input output based hybrid LCA, and here you have the process part and input output part are described in a consistent framework, because we are just updating the IO model. So of course the weakness is that here we have some of the recurring flows that may happen, and separating those out may become very challenging. So there is not many studies that have done input output based hybrid LCA, but there is more and more that is coming up now in the literature. And the last one is the integrated hybrid. This is the most sophisticated one that is out there, and it provides a more consistent mathematical framework for the whole life cycle, and it avoids double counting because you are really taking the process completely out and you have your input output model. It's easy to apply an analytical method, but it is also very complex to actually make, because you have more and more data requirements and time required to build an integrated hybrid model. With that, let's summarize the type of LCA that we have learned so far by system boundary. So one is the process LCA. So we already looked at the process network algebra for computational framework. In this we include all the important processes. So you can do a process LCA for any system that you want. Then we looked at the economic input output LCA, which is more comprehensive and it's a macroeconomic based model. And the idea is that since we are capturing all the interconnections of the economy, we do not miss any indirect impact. So we saw the Leontief model for calculation of the total impact for a final demand, and then using the resource and the emissions coefficient, we can do an environmentally extended input output to do a life cycle impact. Then the last one is hybrid LCA, where we combine the strengths of process and input output LCA. Here there are different types of hybrid LCA, which is integrated, tiered, or the IO based. The tiered hybrid LCA is really straightforward. We will see a quantitative example of it, and that is the one that is most readily used because of the ease of performing. With that, I would like to thank you for looking into this module, and in the next module we will go through some of the problems and we will also go into the life cycle cost analysis. So thank you for coming to this module.